Optimization problem is about a cylinder inscribed in a sphere. So an object inscribed in another object is a very popular optimization problem. So in my video, there is a two-dimensional problem where we have a triangle inscribed in a circle. So this one we have a cylinder inscribed in a sphere. You might see a problem where there is a sphere inscribed in a cylinder. So when you study for a test, especially if optimization is on the test, make sure you study this type of problem. The bad news is this type of problem can be extremely complicated. Let's take a look at this one. A right circular cylinder is inscribed in a sphere of radius r. Find the largest possible volume of such a cylinder. So since the goal is to work on the volume, so that must be my primary equation, and then the secondary, most people might be thinking, all right, other than volume, we also have to find the surface area, right? So that is usually how the problem works. Okay, I gave you a picture, so allow me to make one correction right here. First, I would like to define the radius r to be the radius of the sphere, not the radius of the base of the cylinder. So this r, I'm going to correct that. So this is the center of the sphere, and then from the center to the edge of a sphere, we have r. So I'm going to call this r. So r is the radius of the sphere, or the radius of the ball. And then x, I would like to let x be this, which is half of the height of the cylinder. So this, I would like that to be an x. And then from the base of the cylinder is a circle, right? So this base has a center. And then from the center of the circle to the edge, I would like to call that a y. So that gives me a right triangle. So a right triangle, let's put the right triangle right here. This is r, and this is x, this is a y, this is my right triangle. All right, so now tell me, what is the volume of the cylinder? The volume of a cylinder is the area of the base times height, right? What is the area of the base? So the area of the base is pi r square, right? But the r, I changed the name. The base has the radius of the base is actually y, so that will be pi radius square. That is y. Look at the picture right now, and then times the height. So what is the height? The height is 2x. So v is equals to pi y square times 2x, right? X plus x is equals to 2x. Now we have a volume equation with two variables. So volume is equals to pi y square times 2x. We have to make a substitution because I cannot work with one function with two variables. So how do I get rid of one of the variable? So to get rid of the one of the variable, we need this triangle right here. So this is a right triangle. Using Pythagorean theorem, we have x squared plus y squared equals to r squared. So we have a y squared in the volume function. So let me just put the y squared in terms of x. So y squared is equals to r squared minus x squared. So I am going to put these y squares in here. And then I will rewrite my volume function. Before we rewrite that, so this will be my secondary. X squared plus y squared equals to r squared. So that is certainly not the surface area, right? So this is not about surface area. So we can just cross that out. So now my primary becomes this. So v of x is equals to pi is no longer y squared. That is r squared minus x squared times 2x. So now I am working with one function with one independent variable. And in this problem, the radius is just a constant, right? So we have v of x. We have v of x. That is my function, right? X is a variable. Then the radius is a constant value. Why do I need to point this out? Look at the problem. There is no number, right? So everything is in a variable. So when you solve problems like that, make sure you know which one is an independent variable, which one is not. So since we have v of x, then x is the only independent variable. When we take the derivative, we treat the r as a constant value. All right. So let's rewrite this. So we have 2 pi, right? So 2 pi, they are constant. And then we have r squared minus x squared. And then let's just keep that x outside. And then we distribute the x. You can do this in one step if you like. So we have r squared x minus x to the third. Okay, so now we are ready to take the first derivative. So v prime of x. This is only a constant, right? So we have a 2 pi, and then we have to take the derivative of this. Remember, r is a constant. So this is x raised to the first power. The derivative of that is just r squared. R is a constant, all right? So this is a 3x squared using simple power rule. The first derivative is done, and then you have to set that equals to 0 and solve for x. So solve for x, and then we can divide both sides by 2 pi, so we don't need to work with the 2 pi anymore. That is equals to 0. And then we have r squared equals to 3x squared. And then we have solving for x, right? So we have x squared equals to r squared divided by 3. And then you take the square root on both sides. You don't need to worry about the plus or minus because x must be positive. Because it's about the length, right? It must be positive. So x is equals to the square root of r squared divided by 3. So that is equals to r divided by square root of 3. Okay. And then what are we looking for? You are looking for largest possible volume, right? So this x is a critical number. Since you are looking for the largest volume, so you are looking for a maximum volume. So what we are hoping to see is to get a maximum volume, we are looking for a concave down. So that means when x equals to that quantity, we have the first derivative equals to 0, meaning that we have a horizontal tangent line. So if we get a concave down, that means when x equals to r divided by root 3, we have a maximum right there. So let's proceed to the second derivative. So v double prime of x, v double prime of x, we start right here, right? So that is the v prime. So we still have a 2 pi. And then the derivative of r squared, remember r is a constant. The derivative of constant is equals to 0. And then 3x squared, you bring the 2 down, so that is a 6x. That's it. You don't have to set that equals to 0. And then you plug in the what? You plug in the r over 3, right? So v double prime of x, that is equals to 2 pi, which is a constant. 0 is 6 times r divided by root 3. Okay, look, you don't have any numbers right here. Let me quickly fix that. This is no longer x. This is now a r over square root of 3. Is this positive or negative? R is a unit measurement, right? R is radius. Radius must be positive. So negative 6 is the only negative. So that makes the entire second derivative negative. So second derivative is negative. That means v is concave down. When r is equals to, when x is equals to r divided by root 3. So we have a concave down, and then when x equals to that, we have first derivative equals to 0. That creates a horizontal tangent. That means when x equals to that quantity, we have a maximum. All right, when x equals to that quantity. The problem is looking for find the largest possible volume. They are looking for a volume. They are not looking for just r. R is something you have to report, and they are looking for a volume. They didn't say what the radius is. They are looking for the volume. Can you tell me what the volume is? All right, so when x is equals to r divided by square root of 3, this is half of the height of the cylinder, right? And then all you have to do is you plug in this to the volume function. So the volume function, you don't have to look up. I will copy the function for you. So v of x is equals to pi pi times r squared minus x squared times 2x, and then you know what x is. R is just a constant, so when x is equals to r divided by root 3, you have pi times the r square minus the square of that. So when you square that, the r becomes a square. The square of square root is just a 3, and then you have a 2 times r divided by root 3. And then we simplify this as much as we can. So the pi is not going to go away. So we have a 3. This is a 3r square minus r square. And then this one is a square root of 3. And then we have a 2r. So what is that equal to at the end of the day? So at the end of the day, we have 3 minus 1 is a 2. So 2 times 2 is 4. So we have a 4. And then the bottom is 3 root 3. And then r squared times r is r to the third power, and then don't forget the pi. So this one is the largest volume. So that just answer the question. All right, so that will be the end of this problem. If you think my explanation is helpful to your learning, please give me a subscribe, click the like, share these videos out. I appreciate your help really, really much. I see you all in the next lesson.